Thank you so much for your time. Thank you everyone for joining this webinar. Appreciate your time on this. Looking forward to having a great discussion on compliant AI enhanced unit testing, how AI assisted testing can accelerate test creation while maintaining certification requirements and engineering control. There's a big problem about the manual overhead of C++ unit testing, as it's a persistent bottleneck, especially in high integrity software development. In certified environments, especially with full structural coverage, it can consume a significant portion of engineering time. So, with recent AI assisted development, how can Cantata solve this problem? For this, we have Praveen with us, who is the technical compliance leader at QA Systems Private Limited. So, over to you, Praveen. Looking forward to having a great session. And if you guys have any questions, please feel free to add them on the chat board. We will address all of them at the end of the session.
Thank you, Rahul. Good afternoon, everyone. Welcome to Compliant AI Enhanced Unit Testing. I am Praveen Melepurath, responsible for technical compliance at QA Systems. We make Cantata, a unit and integration testing tool used in safety critical sectors worldwide. That includes aerospace, automotive, railways, and medical device development. During this session, we'll cover how automation using Cantata eliminates the drudgery of unit testing. Second, how that's enhanced by AI agent access. And third, how this works with your AI while ensuring compliance. To begin with, we'll speak about the testing bottleneck. Unit test creation is the single biggest time sink in safety critical embedded development. This depends on who you ask and which standard you're working to. But overall, we have observed that unit testing consumes somewhere between 30 to 50% of the total development effort. When you're targeting something like modified condition decision coverage, MCDC for DO178C, or structural coverage for ISO 26262 ASIL-D, or thorough verification for IEC 62304, the volume of test code you need to write, maintain, and trace is enormous. So the coverage requirements themselves aren't going to relax. The standard tells you what done looks like, but getting them manually is expensive. Now let's look at Cantata, automation that already exists within the tool. Cantata is a testing framework that's been certified, deployed, and trusted in safety critical projects worldwide. Cantata automates test generation, workspace setup, the CSI file generation, framework scaffolding, and all of that is handled for you. It automatically generates controls to stubs and intercepts function calls from the software under test. And it generates test cases from code analysis, from headers for test-driven development, and via autotest for automated coverage gap filling. Going forward, with regard to coverage analysis, Cantata measures statement, decision, MCDC, conditions, loops, and relational operators, all objectively by the tool. It integrates directly into CI/CD pipelines, supporting up to 500 parallel builds. And the same tests can run across host, simulator, emulator, and the physical target board with no code changes necessary. Cantata has been integrated independently certified by SGS TÜV SAR for ISO 26262, EN 50716, IEC 62304, IEC 61508, and IEC 60880. It is also qualifiable for DO178C, DO330. The certification kit comes free of charge. So let me show you what this looks like in practice. We now switch to a demonstration of Cantata automation. So for this particular demonstration, we have chosen a brake control module for an automotive embedded system. So this can be traced through requirements Rec BCM4 through Rec BCM10. And it implements the logic for reading sensor inputs through to computing the final hydraulic pressure target. Its sole external dependency is sensor.h. There are some tunable parameters that you find here as hash defined macros at the top. There are some helper functions in these files, brake.c and motor.c. And there is also a main module that does the actual brake per cycle brake logic computation. You should also note that the apply ABS correction function has a dead buck branch that we have inserted on purpose. What this does is it results in the system um, skipping straight to double reduction and without the gradual pressure reduction step. So with this bit of code, what we are going to do is use the Cantata IDE. Now the Cantata IDE is built on Eclipse. And what we can do is using the Cantata facilities that are integrated in this IDE as plugins, we are going to invoke various Cantata features. So to begin with, we generate a test script for the relevant source files. So having invoked the generate test script wizard, what is first seen is the process of Cantata invoking the compiler and prior to that, pre-processing the files in order to gather information about the software under test. So basically what happens here is it generates something called a CSI file, and the Cantata static information file provides information about the interface to the function under test, the global data that it references, the external calls that it makes, and also the call sequence valid and the call sequences as well. So the process of gathering this information is in this pre-process stage. So you can see it in the console window, wherein the compiler call is prefixed with a call to our wrapper executable. And as a consequence to this, once the CSI file is generated, we have the generate test script wizard, where there is an option to generate an appropriate test script. So in this case, since we are testing a C file, we can name this appropriately. So I will just say breakdemo.c. And I can also choose a suitable coverage rule set. So in this case, since it corresponds with an automotive embedded system, I will choose ASIL-D of ISO 26262 and look at how Cantata proposes to manage the external calls. So in this, automatically Cantata has chosen to generate wrappers. Now wrappers are a more powerful implementation than a stub that Cantata provides. And this allows us to intercept and manage calls as well as change data in either direction with regard to functions that are not just not implemented, but also there within the project. So in this case, wrappers are automatically generated and we can complete the generation and view the test script file. So Cantata generates a test script in the language that is being tested. So in this case, we have a C file that is being generated, and each file has a exact same structure. So it will have an environment definition section. It will have a global data section where all the global data is checked for an expected value against an expected value. And there is the coverage analysis rule set, which is defined. There is a main entry point wherein all the test cases get defined. And there is also the call interface control section where all the wrappers are implemented. Now, to this particular test script, we have an option of either adding test cases through this the source code view, or we can use a user interface, like in this case. So we can simply add a test case, and for that purpose, we can select all the functions that are there within this within the purview of this project and select auto test. And that helps generate as many number of test cases as are required to meet the ASIL-D level of ISO 26262, which means it will try to achieve something close to MCDC coverage. And for that, it has identified around 55 test cases, with the required test data as well as the appropriate checks. Now, in order to see what this report has done, we also generate something like a report about the generation status. And so through this, we can measure how effective the testing has been. So right now it says that full coverage has not been obtained mainly because of the bugs that we have inserted in apply ABS correction. But motor.c has been fully tested. And consequent to that, we can go ahead to build this test. So we can see how this test behaves by executing it in the IDE. And all through this, while we are showing this to you in the user interface, you should note that Cantata has a makefile system, and this makefile system allows the build to be easily integrated into a CI/CD pipeline as well. So you can easily build and run this test in a batch mode on the command prompt. So just to look at the test cases which have been generated and how the results have been. So I will just show you, for example, a few test cases. So we have seen that about 55 test cases have been added. And all of these have the start test, end test block. And we have this relevant data declaration and the call to the software under test. And it's very repeatable. And all these test cases have a structure that you can easily understand and work with. Now, as far as the results go, the results get overlaid onto the software under test, and you can see an overview here in terms of the amount of coverage that we have achieved from the module perspective. We can also see a log file which actually presents in a text format what is the status of the test. So if we scroll down, we see all the test cases have passed, and it's only with regard to coverage that we have a deficiency. So you will notice that this particular view, the coverage results explorer, actually shows this coverage statistics in a more elegant manner. We can see that it's with break.c that there is this deficiency, and we also see with regard to the apply ABS correction that the decision coverage that has been achieved is just 83%. Now, at this point, we understand that there are uncovered branches, but this is the exact work that nobody has time for. And at this point, we need to switch back to our presentation and then talk a bit more about what is the alternative that we provide. So let me just switch back to the presentation slide. Right. So what you just saw is Cantata working entirely without AI. The test generation, the stub management, the coverage measurement, that's all Cantata. But getting from here, what you have just seen, that is 83% with regard to that particular function, to 100% coverage, still takes a human to sit down and write the gap filling tests by hand. So the AI story we are about to get to builds on top of this foundation and not instead of it. So if the AI disappeared tomorrow, you'd still have a world-class testing tool. So Cantata also already does provide you substantially enough to actually reach a significant amount of coverage. And here's the key insight. The AI agent we are presenting is a user of the test tool and not a feature inside it. So in this demonstration, we are using Claude Code, and Claude Code doesn't contain Cantata. It drives Cantata. The same way that you have a human engineer using Cantata's command line interface, the AI agent uses it. So the domain expertise is packaged as a skills pack, a set of instructions that teaches the agent how to use Cantata effectively. So just like you wouldn't embed an agent into an oscilloscope, you'd instead hand them the manual and let them use it, we follow a similar principle. So let's look at the AI-assisted workflow. Here's the workflow. We have 5 steps with the human engineer in the loop at every cycle. Step 1, we analyze. The AI reads your source code, identifies the decision points, the external dependencies, and the control flow paths. Step 2, we generate. Based on that analysis, the AI produces test cases aimed at your specific coverage target, decision, MCDC, whatever your standard requires. And this brings us to the first human review gate. So the engineer looks at the generated tests before they go anywhere. Step 3, we then integrate. The review tests are inserted into Cantata's framework structure. So you will still have the same proper start test blocks. You'll have stub instances. You'll have expected call sequences and so on. Step 4, execute and measure. That is, we compile and run. And this is critical. The coverage measurement comes from the tool, that is Cantata, and not from the AI. Cantata measures the coverage objectively. The AI doesn't get to self-report. Now, step 5, we iterate. So if you haven't hit your target, the AI analyzes the coverage report, identifies the uncovered branches, and generates targeted follow-up tests. Then you review again. So all through, what we observe is that the traceability chain stays intact. Requirements to test cases to coverage evidence. The AI accelerates creation. The framework provides measurement, and the human provides judgment. So this is the AI agent workflow, where it does the heavy lifting and you do the thinking. So let's see how this looks like when we have the AI agent at the workstation. So now we break to a second part of our demo where we use Claude Code along with Cantata and we introduce something new called the trace viewer. So right now we are going to switch to the Claude Code demo. So now we have access to the Claude API and we can confirm the skills that are available to it. We have here the Cantata test automation skill that is available, and we are using a model that is suitable for us. And we can now provide it a prompt asking it to do certain things. Now, if I can just briefly switch back to my the project that I had shown you previously, you will see that there are a number of files within it. And at the same time, I have here the fix for the bug in a separate C file. And I also have the requirements that I spoke about at the beginning as a markdown format file. So I am going to ask Claude to examine these files and to fix the source code and to generate Cantata tests to bridge the coverage gap. So where possible, I will also ask it to prefix the test cases with the relevant requirement reference numbers. So what I'm going to do is just type this as a prompt. So I have asked it to do just that. And now Claude goes about doing it step by step. It starts with the files, tries to understand the requirements in the source code, then looks at the workspace, and then looks at what tests are available, and then goes about its work. So now you will you may wonder as to what it's doing internally. I mean, there is significant amount of work that is happening in the background. And you can easily have somebody from your team asking about what exactly did the AI do. And that's where we have our answer through the Cantata Agent Trace Viewer. So I have run a similar kind of a test yesterday, and for which you can actually see that with a similar kind of a prompt, you can actually see step by step as to what the AI agent did at every stage. So this is something that we plan to open source soon. And so you will be able to use the same viewer for understanding the agent sessions and to provide a log or possibly something that can be used for an audit. So here we have gone through similar steps where it's going through files and it's actually looking at the results and also looking at the existing test scripts and then going forward to identifying where the gap is and then subsequently doing understanding what it needs to do. So it goes about identifying the bug in the code and then fixes that to start with, and then subsequently it adds further test cases. And so you will have to see at various stages at where it is inserting the calls. And so you can obviously go back at any point in time, look at the modified test script, and then make changes, and then ask Claude to look at it again if required. And so at various points in time, it iteratively goes about confirming that the work it does is identical, and it goes about inserting the calls in the right places. So previously you had seen there were 55 test cases. It goes about in one instance adding 3 additional test cases. And now you should also observe that it's non-deterministic. So if I, for example, take this run and probably take another run that I did yesterday, you will see that at various stages, it probably accomplishes the same thing with a different number of test cases. So that's the non-determinism at play. But what matters is what is the end result. So you can obviously come to a stage where it actually does the modification, and then it tells you as to what the changes are that it has done. And it then tells you that what you need to next do is to build and run the test. So at that point in time, it is possible to actually just look at the modified test script. So I will just take up a previously modified test script and then show you as to how the changes look like. So if I, for example, look at this particular test script and then look at the additional test cases that have been added, you will see that for every test case, it will do exactly what we had asked it to do. One, in terms of the requirements, and two, in terms of the additional test cases. So you will see a reference to the specific requirements that the new test cases meet. And you will also see an exactly identical structure where the test case data is being declared, the call to the software under test, the checks, and the globals. So in this particular instance on a previous case, we had Claude achieving the required objective with just 2 additional test cases. So it is possible that you can then, having obtained the modified test script, you can simply just rebuild and run it in order to see the results. So we are now switching workspaces. So let's just go back to this and let's see how it behaves. So this will take time. So it just asks me for prompts as to when it goes about its tasks. So this is not as time consuming as probably a human actually going about the job of adding further test cases. So this is considerably short, but during the course of a demonstration such as this, it may not be feasible to present the entire operation, but to instead show exactly what steps were happening in the background by means of the agent trace viewer. So this is basically the approach that we want to speak about, but we can provide more details about this through presentation slides. And what we can observe is after this, after we have uh, confirmed the changes in the particular IDE and then asked Claude to go about and rebuild the test, you can confirm that the required full coverage has been achieved. So you will see that in all most cases, or in nearly every case that I have exercised this code previously, it does achieve the required objective of 100% coverage, and in considerably less time. So if you look at the start and end timestamps, it's probably just about 20 to 30 minutes that the entire operation takes. So this is a considerable time saving, and at the same time, it's a new approach that we recommend uh, for use along with Cantata. So let's switch back to the presentation slide where I can elaborate upon what happens in the background. So the workflow is basically doing the same thing. It's analyzing, it's generating, it's integrating, executing, and iterating, with a human reviewing it at each cycle. And the trace viewer provides a full audit trail of everything that the agent did. Now, when we use an agent in this way, we are obviously concerned about governance and certification. The AI produces good work, fast work, and you will obviously have questions of whether we can use this for certification. Now, the answer is yes, with the right governance. For example, for DO178C, the AI is not a qualified tool. It doesn't need to be. The AI is an assistant that produces draft test cases, like we have seen. The qualified engineer reviews and approves it. The coverage measurement comes from Cantata, which is a qualified tool. So nothing in DO178C prohibits this. As for ISO 26262, the AI-generated tests are artifacts that pass through the same review and approval gate as manually created tests. The method of creation is secondary to the review. Coming on to another standard, IEC 62304 for medical devices, traceability documentation is the key requirement. The tests exist, the coverage is measured, the review is recorded, and how the test was initially drafted is secondary to whether it was properly verified. So therefore, the governance checklist is simple. Every AI agent uh, has a test which is reviewed by a qualified engineer. The coverage reports are from the tool and not from AI, and the AI usage is documented in your process. The standard traceability chain is maintained throughout. Now, at this point, let's stop to pause about what the AI can get wrong. So to be honest about the risks, you need to manage them and not ignore them. So we should be aware of what the risks are. Firstly, what I think everybody is aware of is hallucination. The intern writes a test that compiles, runs, and passes. But it tests the wrong behavior. It asserts the wrong expected value. That is why coverage measurement is necessary, but it's not sufficient. You need human review of the test logic, not just the structure. So this is the same as reviewing a junior engineer's work. The second risk that we need to be aware of is data privacy. So if you're sending source code to a cloud API, you need to understand that your data processing agreement. So enterprise API agreements with providers like Anthropic provide contractual protection. For the most sensitive projects, on-premise LLM deployments exist. So it is very important that you know your obligations. The third risk is something that I touched upon earlier, non-determinism. The same prompt won't always produce the same tests. I have mentioned that as well. That's fine, but because you get to review each output individually. And don't assume that because it worked perfectly yesterday, tomorrow's or today's output is also correct. So the practical advice that you can follow is to hand the AI agent, not to hand your AI agent the most safety critical module on day one. You start with a backlog. A module where, for example, coverage has slipped to 60% and nobody has time to fix it. And that's where the ROI is highest and the risk is lowest. Now, let's examine another question that changes everything. There's something interesting that's happening across the industry. Every team is hiring their own AI agent, and they're not all hiring the same one. Some teams use Claude, some use Copilot, some others use Codex, Gemini, Goose, and this creates a strategic question for every tool vendor and every tool buyer that they need to answer. So there are two ways that you can respond to this AI revolution. So if you make developer tools, one of them obviously is a trap. The philosophy one says our tool uses AI. So you basically bolt an LLM into a product, the vendor controls the model, and you're locked to one integration. And when the model changes or the customer's company standardizes on a different agent, it breaks. Now, the second philosophy is our tool works with your AI. So basically, you treat the AI agent, as I have explained, as a user. Give it the same CLI access that a human has, and package your domain expertise as skills that the agent can load, which is what we have done. And the customer can choose the agent and their model. So here, when we built Cantata's AI integration, we didn't embed an LLM. We wrote a skills pack. And the set of instructions teaches any compatible AI agent how to use Cantata. The agent basically reads the manual, and we don't surgically implant the manual into the agent's brain. So coming to the skills pack ecosystem, let's talk a bit more about that. So what is a skills pack? So it's basically a portable directory of skill.md files which contain domain expertise, workflows, and automation instructions. So the agent loads a skill, it follows the instructions, and it drives the tool. So this started as a Claude Code concept, but now it's an open standard, which was announced in December of 2025 and is now being adopted across the industry. So today, we are verifying this Cantata skills pack that you have seen working with Claude Code also works with other AI agents. So we are currently exercising it with Copilot and so with OpenAI Codex, with Gemini, Cursor, Goose, Block, AMP, VS Code, and many more. It's currently about 16 plus agents that we have planned for, and there are 16 plus agents who can read the same manual. So you have one integration with no lock-in. So we also understand that every agent will not implement the standard identically. So if your organization has a preferred agent framework in use, we are happy to work with you to ensure that the Cantata skills pack works smoothly with it. Now you could look at why Cantata was always ready. So some of them lies in the way Cantata was constructed. We did not actually see the AI agents coming and re-architect our tool. So we didn't need to. The reason is that Cantata was already built in a way that an AI agent wants to work. Firstly, it's code centric. So our test scripts, as I have shown, are written in C and C++. So that's plain text which any LLM can read, generate, and modify. And there are no proprietary visual editors and no binary formats. Second, it's CLI first. So every GUI operation has a command line equivalent. So AI agents don't click buttons, but they run commands, and Cantata speaks their language natively. Now, the third is ASCII outputs. Our coverage reports, our test results, our diagnostics are all readable text. So the AI agent can parse them, it can reason about them, and it can act on them without screen scraping or API wrappers. So we didn't build an AI adapter. What we discovered was that our architecture already was one. And now we are actively expanding Cantata's CLI surface area so that every capability is AI agent accessible. Now, with the skills pack standard already published, tools like Cantata that were already code-centric and CLI accessible were already compatible. The ecosystem has now caught up overnight. Now, one more thing, when adopting AI for testing, that's often the very first step in a broader organizational AI journey. So we can also help with the next steps. You have seen the Claude Code Trace Viewer for visualizing and auditing AI agents. So we are open sourcing it soon. And you're free to subscribe to our newsletter for the announcement. And we also offer something called an AI controller, which is basically an enterprise gateway for secure managed AI access. It provides centralized security, audit trails, cost tracking, and instant provider switching. We can also advise on private AI compute to power your agents for organizations that need full data sovereignty. Now, just to summarize, there are 5 things that you could remember. You could possibly look at the numbers from real deployments. What we have seen from real case studies is that 40% or more reduction in test creation time is observed. For example, in published research on the PX4 open source autopilot, a real flight similar controller, AI-generated tests achieved something like 98% statement coverage and found 14 previously unknown defects, including 2 medium severity issues in flight path calculations. So to come to the points to remember, Cantata already automates the structural work. For example, the test harness generation, the stub management, coverage measurement, the CI/CD regression. The foundation is solid, so with or without AI. Second, our AI agents are the new users of our test tools. You can treat them as team members who need a manual, a skills pack, and not as features to bolt into a product. The third point that you can remember is the iteration loop is where AI delivers. Our first pass generation will just get you started, and coverage aware gap filling is where the real productivity gain lies. 4, you can note that certification compliance is maintainable, human reviews and along with tool measured coverage. So, and documented AI usage. So the standards don't prohibit this. Five, openness wins. So we have one skills pack. We have planned 16 plus compatible agents with no lock-in. So all you have to do is ask the vendors the right questions. The AI agents future is something that we now need to speak about. So we note currently that agents still need supervision. They can still get things wrong, but the team will obviously be faster. The coverage numbers will climb, and senior engineers of your team will spend more time on judgment calls instead of tedious gap filling. And here's the best part. If the agent quits, for example, if the model changes, if the agent framework evolves, or if your company chooses to switch AI providers, the workshop doesn't change. Basically, Cantata is still there, the tests are still there, the coverage evidence is still there. And so you just hand the new agent the same manual. So this is what we have done by means of building tools that work with AI rather than having a tool that uses AI. Now, this is what I prefer you do. You can pick up one module from your backlog. You can try the Cantata Skills Pack with your preferred AI agent and measure the results. And you can talk to us or to Meteonic about compatibility with your specific environment. So if you want to stay connected, you can subscribe to our newsletter at qa-systems.com for the Claude Code Trace Viewer, its open source release, and other AI tooling updates. Thank you. Now I'm free to take questions.
Thank you so much, Praveen, for a very in-depth session. This kind of a very wide topic, and you kind of summarized it in a very quick 30-minute conversation. Vishal had a question regarding EN 50716 standard or EN 50128 standard. Could you could you elaborate on this? Could you help him on this particular thing? How does
Yeah,
Cantata help
so
with that?
Yeah, thank you, Rahul. So, EN 50716 is something that Cantata has been certified for. It's the new railway standard and something which I personally have worked on. And what I find is that whatever we have spoken about with all the other standards also applies to the railway standard. So, there is nothing within the standard as such which prohibits you from the approach that we are suggesting, because it allows for review at every stage, and that is something that easily fits into the standard. So just like you have with EN 50128, which was a precursor standard, we have similar guidelines and Cantata compatibility that has been established through our standard briefing. And so with the tool, you also get a free certification kit that actually helps you to meet your certification requirements and walks you through the various stages. So it provides guidance on every aspect of the certification. So from that perspective, you can be assured that our certification kit, along with the guidance that we provide within it, will definitely allow you Cantata usage in this manner for your railway projects.
Hope that has answered your question, Vishal. If not, please feel free to add on to another comment on the chat box. We will be happy to address them. Another question was from Kishan on which other IDs can Cantata be used with?
So what we have shown you during the demonstration is Cantata installed as plugins within the Eclipse IDE. We also have very strong integration with the Visual Studio Code development environment. And similarly, we have integrations that are available for most cross-compiler development environments. So our tool has been in the market for about 30 years. And so with every target deployment, we have a very close integration with that specific environment. So the main two development platforms for which Cantata has very close integration, as I mentioned, is Eclipse and VS Code. but the other IDEs are also equally amenable, and Cantata can easily be integrated. And we have proof of usage across projects over the last 30 years for every possible cross-compiler target environment that is there in the market right now.
Thanks. I think that has answered his question as well. I also had a question. Was so what kind of improvement in efficiency would one expect if they adopt, this AI assisted testing for their projects?
Yeah, so like I have mentioned in one of the slides, Rahul, what we have observed from actual use cases that we have seen through open projects that we have run the tool in, there is at the very beginning itself a 40% improvement in terms of productivity. And that in some cases is much higher. So that is the base figure that we have observed, and that is what we can communicate. But I am sure this figures will improve as AI agents evolve, capabilities improve, and as our skills pack and the integration also matures.
Right, absolutely. I think Kishan has a follow-up question. For Linux environments, can it generate G tests?
Yeah, so Google Tests, I presume, is what you are actually looking at. So Google Tests basically is an open source alternative. I mean, it's something that has its own proprietary format, or it's not proprietary, it's an open source format where it generates test scripts. And what we offer is something called Cantata Hybrid. Now, Cantata Hybrid basically allows you to actually use G-tests and or Google tests and convert it into a Cantata test script format and measure coverage. Now, the advantage of doing that is Cantata being a certified tool allows you to easily achieve certification for your existing Google tests. And so you can actually simply reuse your existing Google tests and add on Cantata coverage to it, and then get the report in a Cantata certified format. So this is the approach that we are providing, and the tool that we provide for this purpose is called Cantata Hybrid, and that is available on the Linux environment.
Yeah, there's one more question around, how does Cantata stand against your friendly competition like Vectorcast or any other testing platform?
Yep. So one is the openness of Cantata. So basically, you are testing in the same language that you are coding. So basically, that openness is something that uh, is quite unique to Cantata. The other thing is there are specific features, like for example, Cantata wrapping, for example, which is a USP in comparison with our competitors. And at the same time, we fully understand that our competitors also evolve in terms of their product features. So we would not like to do a feature to feature comparison as such, but what you will see is that Cantata behaves or provides equivalent or better features in most contexts in comparison with all the tools that are competitors to us in the market. In terms of tools which actually work in proprietary formats, you will find that they are not as amenable to this AI approach that we have shown you. This is something that is only possible with Cantata because of its openness and because of the way the tool has been architected. And that allows an AI agent to easily integrate and to behave just like a normal user would. And at every stage, you are able to see the productivity gain. You can let the AI agent run, you can review whatever it has generated, and you can make changes, or you can recommend or ask it to improve. And then you see that you are able to achieve much more in a considerably less time. So, along with the existing base features of the tool, I am sure that we provide a much better value proposition in comparison with the competitors currently.
Yeah, just to add, I'm Saravanan here. You're able to hear me?
Yes, Aravind sir, please go ahead.
Yeah, a key thing to notice when you're actually going ahead with a testing tool, whether the OEM's presence is in India. So obviously, because you need to have a lot of handholding measures that needs to be done. Plus, we provide global support technically sitting in India. So obviously, you need to be assured of the technical presence, the presence of the OEM in India, and the kind of customer base. We build the customer base in India for the last 30 years. So it's not only a question of the features and functionalities, what kind of post-sales technical support we provide, what kind of licensing technologies we provide, how we adopt to different scenarios in terms of the platform environment, both on the host as well as on the target. And we have multiple licensed technologies as well. So if there's any query on the tool perspective and the license and commercial, we can always take it off.
Thanks for that, Saravanan sir. I think there is a follow-up question from Sudhir. Is multi-core testing possible on Cantata?
By multi-core, I presume that you're referring to processor cores, right? If that is the case, it's something that you could definitely try out, and it's something we don't have the necessary project level information in terms of actual ground usage, but it's something that we can definitely work with you, and I'm sure Meteoni can also offer you an evaluation such that you can be assured about the support that Cantata provides.
Hope that answers your question, Siddhi. If you would like to book a one-on-one session, I have provided the link on the chat box. We can maybe, do that one-on-one. So there's one last question from Sagarika. What are some common mistakes that we should avoid while using prompts for this particular testing environment, especially when AI is concerned?
Yeah, so essentially, that's more a question of AI etiquette rather than cantata use. But I'll try to answer it in a way that basically is like advice an IT administrator would possibly provide to users within an organization. Essentially, you have to be very careful about what you expose to the AI agent. So when, for example, you run a prompt, there are instances where it asks for permissions, and there are the permissions are with related are with relation to operations that it needs to perform, are with relation to file access that it needs. Now it is obviously your decision to make as to how is it that you are interacting with this AI agent. Is it something that is on premise, which means it acts within the safeguard of your organizational firewall, and you have sufficient control on its usage, or are you sending this data across the cloud to an API that works remotely? So from that perspective, you need to understand about data access and the necessary safeguards that your organization recommends, and you need to make decisions based on that. So ideally, I would say do not expose your entire code base to it. Just try to expose whatever is minimal and what is required for the test at hand, and at the same time ensure that your privacy settings for the agent are set in such a way that it does not use this for its training purposes. So I think with those preliminary safeguards in place, you should be good to go. I mean, you can provide it any prompt. The text of the prompt is irrelevant. It's all a question of how you respond subsequently to it when it asks you follow-up questions asking for permissions. So that is where you need to be careful.
Hope that answers the question, Sarika. Thanks for that, Praveen. Appreciate I think generally the answer when it comes to IT is configuration management and settings.
Yeah, it does. So it's a learning experience for all of us, especially with our increasing AI usage. And we are obviously reaching a stage where overall productivity increase is observed. So we are happy to actually provide Cantata in a manner that increases your productivity with regard to unit testing. And I'm sure with Meteonic, we look forward to further engagements in enabling its use in your projects. Thank you, Rahul, for the time, and we hope all of you have uh, a happy testing experience going forward. Thank you.
Yeah, I have one last question, Rahul.
Yeah, please go ahead, sir.
Yeah, I would like to know among the audience, have how many people, how many of them have used Cantata? I just would like to know if any existing customer is already there who's using Cantata. And obviously, we also have a static testing tool called QA Misra. So these are our standard offerings, both the dynamic testing and static testing. So I would like to know if anybody is using any static testing tool or anybody is using Cantata or any other testing tool. I'd be keen to have some further conversations with them post this meeting.
Right, absolutely. Without knowing what kind of, if anyone has used Cantata or QA Mistra for their static application security testing or Cantata for their functional testing, please let us know so that we can maybe engage with you on how your experience has been and if there is something that we can improve on or we would love the feedback.
Yeah, and to add to that, we are willing to offer free demonstration of both of static and dynamic testing tools, that is QA Misra and Cantata, and we can also provide free evaluation for 30 days for both these tools. So if anybody is keen to look at further in-depth demonstration of both our offerings, and we are willing to also provide 30-day evaluation for these tools as well. So all this will be done via Meteonic.
Right, absolutely. We are more than happy to help in kind of evaluations or testing that any organization or individual needs to have. Uh, as Ravanan said, we are more than happy and keen to work with you guys. So if you guys have something in mind you would want to see more, explore more, please feel free to reach out. I've already shared the Calendly link on the chat. Looking forward to connecting and helping you do unit tests quicker. I think if there are, and we can leave that on.
Okay.
Interested to receive the training for static and dynamic testing. Okay, Sarika, would love to connect with you after this meeting.
Just to keep you informed, Rahul, I think Sari.
For your appreciate all the inputs that you have and looking forward to staying connected and seeing how we can help with unit testing and helping QA systems.
Thank you. Thank you for facilitating this and happy to participate in this
Yeah,
webinar.
thank you. Thanks, Praveen. Thanks, Rahul and Pooja.
Bye.
Thank you everyone for your time.